Hello students, today this video will talk about the basics of LCM and HCF in number systems, right? So first let's talk about what do we mean by HCF, also known as GCD, right? So HCF is actually highest common factor. GCD is called greatest common divisor. It's basically talking about the same thing. So first let's understand what do we mean by factor, right, or divisor in a way actually. So if I am talking about a number like let's say 12 and I am talking about the factors are our divisors are basically the numbers which are smaller than the number are equal to at max and can divide this number leaving a remainder of 0, like 1. When 12 is divided by 1, the remainder is 0. 2 6 are 12, so yes, it's a factor. 3 4s are 12, yes, it's a factor. 4 3s are 6, right, and then 12, right? All of these are the factors of 12, right? So let's say I have one more number like 24. What would be the factors of 24? 1 2 4, oh 3 as well, 3 8s are 4 6s are, right, 6 4s are 8 3s are, and then 12 2s are, and 24 as well, right, 24 1s are. So if I'm talking about highest common factor for these two numbers, right, so what are the factors I see? 1 and 1 is a common, 2 and 2 is also common, 3 and 3, 4 and 4, 6 and 6, 8 is not here, 12 and 24 is not there. So what is the biggest number which is common? 12, right? So that's the factor. So HCF is 12 for 12 and 24, right? So this is what the highest common factor is. So factor or divisor is basically the same, the number which can divide the number leaving a remainder of 0, right? Now let's get to this point of how do we calculate HCF and GCD, right? In the previous slide we talked about 12 and 24. We listed the factors. What will we do if the number is something like 200 and right, like a big number, let's say 243 and 81, right? It will take you time to list out the factors and do it. So there are multiple ways to find out the HCF and GCD. So one of the common way is right, it's called prime factorization way, right? So once you know the factors of the numbers we are talking about, you can actually find the HCF. Like let's talk about the same example of 12, right? So what do I mean by prime factorization? So basically, you do the tree to find out the factors. So it's basically 2 into 2 into 3 is 12. So 2 power 2 into power 1, right? So what about 24? It's 2 into 12, 2 into 6, 2 into 3. So that's basically 2 into 2 into 2 into 3. So that's 2 power 3 into 3 power 1. So when I'm talking about HCF of 12 and 24, right? So these is the prime factorizations of those two numbers. So what will I do? I'll first look at the first prime number that's common, right? 2. So what is the smallest power I see here? I mean 2 power 2 is the smaller one than 2 power 3. So I will take the smaller one, 2 power 2. Right, and then I have 3 and 3 here as well. So 3 power 1 and 3 power 1. So the smaller is basically both of them are small with respect to each other. So I'll take 3 power 1. So 2 power 2 is 4 into 3 is 12. So the HCF is 12 for the numbers, which is what we have seen in the previous as well. Right, other way is something similar to how we divide things, right? The circle brackets. So let's say I have two numbers, I'll do 12 and 24, right? So 12 2s are 24, so it's ending here, so I know that this is the HCF of the number. Okay, let's try something else to clarify this. Let's take 28 and 42, right? So I start with this smaller number dividing the bigger number. 28 ones are 28. So I get 14 as the remainder. 42 minus 28. So I'll get this 28 here. Now I know 14 twos are 28, can divide it, and 0. So hence I got the remainder 0. HCF is 14 for these two numbers, 28 and 42. Right, this is how you find it. So you have both the ways for us. Right, you take the prime factorization where you do this dividing depending on how you're comfortable with. So let's get to the least common multiple known as LCM. Right, so when we talk about LCM, first let's understand what we mean by the multiple part, right? Sorry. So the multiples are basically, if I'm talking about the multiples of 4, that's like 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 24, 28, and so on are the multiples of 4. Let's talk about the multiples of 12. 12 ones are 12, 12 twos are 24, 12 threes are 36, and so on. And if I'm talking about, let's say, 20, right? 21s are 20, 22s are 40, 23 are 60, 24 are 80, and so on. So let me try to find the LCM of all three, right? So if I keep writing it, I see 20 here. At some point I'll see 40. At some point I'll see 60 and 80 as well as multiples of 4, which is what I'm seeing here for 20. Right, and then if I'm talking about this, 36, 12 4 are 48, 12 5 are 60, and so on. Right. So what are the common? First I see 20 and 20, but I'm not seeing the 20 in this list. Then 40 and 40 I'm not seeing again here. 60, yes, I'm seeing. Sorry. And 60 I'm seeing here. And 60 I'm seeing here, right? So that's like the common, and that's the smallest. If I keep writing, I'll get 120 here and 120 here as well and 120 here as well. 26 are 120, 12 10s are 120, 4 30s are 120. That is also a common multiple. Like 240 is also a common multiple for all three, but LCM is basically the least, right? So that's fundamentally 60, 60, and 60 is the least. So LCM is 60 for 4, 12, and 20. Again, how do you calculate LCM for numbers? Two ways, like how we have seen, right? One is fundamentally the prime factorization way again. Right, let's talk about 4. That's 2 into 2. That's 2 square. 12. 2 into 6. 2 into 3. That's basically 2 power 2 into 3 power 1. And 20 is 2 into 10. 2 into 5. Sorry, 2 into 5. So that's basically 2 power 2 into 5 power 1. Right? So how do we do for LCM? For all three, I'll first look at the prime number 2, which is common. Now instead of taking the smallest, which we have taken, right, the powers wise the smallest in HCF, I'll take the largest, which is fundamentally 2 power 2 here for all three, luckily. Then I'll see 3, right? Here I'm not seeing 3, I'm not seeing 3, so that's indirectly basically 3 power 0 is 1. I can also write this as 3 power 0 because 1 and 1. So fundamentally, if you are not seeing a number, that means the power is 0 for them. So I'll take the highest power, 3 for 3, that's 3 power 1. And then for 5, 5 power 0, 5 power 0, and I see 5 power 1 here. So that's the highest one. So that is basically 4 2 square into 3 into 5. That's basically 12 5 is 60 is what the LCM is, right? Which is what we've got in the previous one also. And the other way is, second approach, which we would have done in school, is writing the numbers like this: 4, 12, and 60. Now I'll try to take a common prime number which can divide all of this, a factor or a divisor basically. 4 is not a prime number, but so let's do with 2 if you want. 30. We can also do with 3 and 15, right? Now I can't divide with any other number 1, but if you have multiple numbers, the logic is if I can write any prime number here which can divide 2 of this, even that is a good enough one for us. So I won't touch the 1, but 3 ones are 3 and 3 5s are. Now I stop it here because I can't divide further. So it's fundamentally 2 into 2 into 3 into 5. That's again 60 basically, right? This other way that you do to find the LCM, right? So couple of other properties which would help us, solve few problems. So if you want trying to find the HCF of fractions, so that's basically HCF of numerators by LCM of denominators, right? Let's say I'm trying to find for 1 by 2 and 1 by 4 HCF. So what is HCF of numerators is 1 comma 1. HCF is 1 itself, and LCM of 2 comma 4 is 2, so that's why it's 1 by 2, right? So 1 by 2 comma 1 by 4, the HCF and LCM as this. So if I'm trying to find the LCM of M, 1 by 2 and 1 by 4, the LCM, first I'll take the LCM of the numerator, so that's again 1 comma 1 is 1, and HCF of denominator is 2 comma 4, is highest common factor is again 2, right? For these two. So if I'm talking about it, so LCM of 1 by 2 comma 1 by 4 is LCM of 1 comma 1, which is 1. That's a common multiple, the least common multiple. And HCF of 2 comma 4 is 2, which is the largest one that can divide both. It's something similar for here as well. So 1 by 2 and 1 by 4. So HCF is 1 for the numerator, and LCM of denominators is 2 comma 4. LCM of 2 and 4 is fundamentally again the least common multiple is 2, which can divide both. Right, so other properties, HCF of two numbers into LCM of two numbers is basically product of these two numbers, right? So that's like HCF into LCM of those two numbers should be fundamentally the product of those two numbers. So let's try to solve a few problems. We have actually listed 3 problems covering the concepts. So we have explained how you do HCF and LCM. That's how we cover the basics part, but that's not how you actually get the questions in the exams, right? So you'll actually get some application oriented. So very basic application to give a gist of it. Let's assume that Ram has 56 biscuits, right, and 40 chocolates with him. He likes to distribute it to kids such that each kid gets equal number of biscuits. Like let's assume to make this right compared to other kids, as in each and every kid should get equal number of biscuits when they are distributed. Similarly, equal number of chocolates as well compared to other kids. That's basically each and every kid in the group should get equal number of chocolates when they're distributed. So let's assume that there is only one kid, right? So that means he'll get 56 biscuits and 40 chocolates. So that's like satisfying the condition, right? Let's look at two kids, right? That means each kid will get 28 biscuits, 20 chocolates and 20 chocolates, right? So both of them, both kid 1 and kid 2 got same number of chocolates and same number of biscuits. That's the criteria that is being satisfied. Let's try to take 4 kids, right? 14 biscuits and 10 chocolates, 14 biscuits and 10 chocolates, 14 biscuits and 10 chocolates, and 14 biscuits and 10 chocolates. So same, right? Each kid is getting the same number of biscuits and each kid is also getting the same number of chocolates. So this is looking like a correct answer. This is looking like a correct answer. So clearly look at the question. It says what is the maximum number of kids that Ram can distribute while satisfying the condition. So that's where basically, all of these are factors. One is a common factor for both. 2 is also a common factor which can divide 56 and 40. 4 also can divide 56 and 40. So that's where basically it's fundamentally asking us to find the HCF of 56 and 40, the highest common factor, right? All of these are common factors, but I'm trying to find the highest. So like let's do the division way that we know. 41s are 40. So 16 is a reminder. 16 2s are 32. 8 2s are 16. So that's why the HCF is 8. So 8 kids is the maximum that I can distribute. Each kid will get 7 biscuits and 5 chocolates, right? For this. So this fundamentally the way you see the questions instead of directly asking you to find the HCF of 56 and 40. Right. Other question here you see there are two bells A and B. They rang together at 6 a.m. basically, and bell A rings every 10 minutes and bell B rings every 15 minutes. So that means, let me write first. 6 o'clock bell A rang, then again it will ring at 6:10. 6:20, 6:30, 6:40, and so on, right? For B, it's basically 6 o'clock, 6:15, 6:30, 6:45, and 7 o'clock, and 7:15. And I keep writing it. So 6:50 and 7:10, and so on. You see, they're asking when will they ring together again. See, 6 o'clock they're starting. Again, I'm seeing a common ringing time at 6:30. Again, they ring together at 7 o'clock, right? So this is fundamentally what are this 0, 10, 20, 30, 40, 50, and then 60 is fundamentally 1 hour. So again 7 o'clock, 7:10. So these are multiples of 10, right? 10 minutes, 20 minutes, 30 minutes after 6. And for 15 minutes, 15 minutes, 30 minutes, 45 minutes, again the multiples of 15. So when do they ring together? I am trying to find the LCM basically. If I find the LCM of 10 and 15, right? I'll stop here. So it's basically 5 into 2 into 3. So that's 30. Every 30 minutes, right? At least common multiple is 30. So 6 and then 6:30. And then again after 30 minutes, 7 o'clock they ring together. Again at 7:30 and 8, 8:30. I see this keep ringing together. Right. So the first time they ring together at 6:30, again after 6. How many times will they ring together by 10 a.m., right? So I know that every 30 minutes they're ringing. So in 1 hour they'll ring 2 times. So 6 a.m. to 10 a.m. there's basically 4 hours. So that's basically 8 times. So by 10 a.m. so should I count 10 a.m.? So that's when they ring the 8th time, right? They ring by again. So it's by 8, 10 a.m. So that's okay. That's not the essence of the question. Understand that it rings every 30 minutes and that should be clear. Last question for this video. So we're talking about HCF of two numbers is 72 and LCM of these two numbers is 12. If one of the number is 24, find the other number. Right? If you remember that we have seen the property HCF of two numbers into LCM of two numbers is basically the product of the two numbers. So 72 is HCF of two numbers, 12 is the LCM. I know that one of the number is 24. Let me find the other number, right? 12 2s are 236 are. So the other number is, so that means the other number is 36, right? So this is the property which would help you to solve problems like this. So that's it for this video. So you can take the quiz assessment available after the set of videos on number systems, and we'll get into details of some next level problems in those problems and the solutions for those problems. Thank you for watching this video.